The International Society for Photogrammetry and Remote Sensing is involved in mapping, monitoring and modelling of our planet Earth at different scales. This is a brief introduction to our science, profession and the tasks of our organisation. Applications. Data at all scales is used in mapping, monitoring, modelling and management for the benefit of our society. Our roots are in mapping from aerial photography. This is still a very common task today. Today we also use new sensors on aircraft and on satellites. This widens the range of products and enables mapping from space, both of our planet Earth and of our neighbouring planets. Data from satellites also allows monitoring at small scale, very frequently for forecasting activities on Earth. New sensors enable us to look at small parts of the electromagnetic spectrum to help monitor the environment. Other sensors and processing techniques assist in monitoring our landscape and its sustainability. Radar sensors penetrate cloud and allow images to be obtained in all weather, which is especially useful for monitoring natural disasters. New high-resolution satellite sensors provide fine details and hence the land use dynamics. Airborne sensors help to analyze the terrain at the highest resolution. Data from several sensors can be combined to help in disaster management. Three-dimensional models of cities and heritage sites can be created by using new technologies, and these can be used for planning and documentation. This can also be done at very large scales for visualization and documentation of the cultural heritage sites. Our technologies can help to maintain the quality and the security of industrial products. And keep track of movement using robotic sensors. These can be applied in industry and in the medical field. Members. Who is involved in ISPRS? Who are the people at the grassroots of the society? Professor Dolleschal was a professor for practical geometry in Vienna, Austria, with a great love for photogrammetry. In 1910, he considered the time was right for worldwide cooperation of photogrammetrists. ISPRS was founded in Vienna on the 4th of July, 1910. National organizations from many countries make up the core membership of ISPRS. Companies and research organizations join ISPRS to enhance cooperation with users. Scientists from institutions and universities participate in the ISPRS through membership of working groups. The ISPRS brings people together for solving practical global problems with modern technologies, for data capturing and analyzing and interpreting the data using sound scientific methods. Sensors. Scientists and engineers are working on the development of sensors. Innovation takes place in the development of high-resolution satellite sensors as well as missions with the Space Shuttle Endeavour that carried an innovative radar system for terrain mapping of our Earth. A new generation of aerial cameras enables rapid access to the recorded imagery in combination with airborne scanners with laser technologies which detect the surface of the terrain. Digital cameras will increasingly replace traditional instruments for close-range applications and are often combined with terrestrial laser scanners to accurately detect the surface of 3D objects. Well-known photogrammetric technologies have been adapted for industrial purposes. Optical sensors at even closer range support medical applications and control activities of robots. Data extraction. Pre-processing of the data is important before information can be extracted for the later analyses. Image processing and analyses deliver input for geographic information systems. "3D information can be extracted accurately from aerial imagery. Buildings can be measured and finally animated as well as cultural objects analysed for virtual reconstruction. Data for industrial quality management must be determined with sub-millimetre accuracy. "3D data are captured for human health and also stored to control movements of robots. Products. The analysis of the data, the achievement of reliable results and the preparation of a quality final product, both for end users and scientific research, requires good expertise in many areas. Satellite data are the most important data source for our daily weather forecasts, which can help us prepare for natural disasters. Satellite imagery can assist in monitoring Earth movements, which can be used to predict global disasters. Simulations help planners to understand and visualize the risk of natural disasters on risk maps. Maps are still welcomed by end users. They're an important base for the discussion with decision makers. "3D city models enable the visualization of planned activities in cities. Multiple source and multi-scale data must be managed in a geodata server in a proper and certificated way, one of the biggest tasks of today's data management. Spatial digital data are available for Internet applications. User-friendly environments support a wide use of remotely sensed data. Geodata is an ideal support for market analyses for guiding wise and financially sound investments. Mobile applications using cellular phones, GPS, internet and mobile computing provide the necessary support for users. The results of our modern technology help archaeologists to do their work better and visitors to understand our cultural heritage. Computer specialists reanimate long destroyed or forgotten cultural objects using real data and refine them into a virtual world. Cars can be controlled by sensors and suitably adapted software tools for quality management. The results can even be used for the control of machines. Organization. What is the structure of the ISPRS? To work on so many different tasks, the ISPRS has formed 8 technical commissions and about 60 working groups. ISPRS brings together scientists from all over the world. Our work is published in the ISPRS Journal for Photogrammetry and Remote Sensing, the ISPRS Archives and the ISPRS Book Series. News and reports are published in ISPRS Highlights, our quarterly news bulletin. We support technology transfer for developing countries and new training technologies like e-learning, and founded a youth forum in order to transfer knowledge to the young for the future. We cooperate with many other organizations such as the International Committee for Architectural Photogrammetry, SIPA, for documentation and preservation of cultural heritage. We cooperate with the United Nations and many other international organizations and societies. www.isprs.org